Welcome to Geometry to the Point and Beyond using the Ghpython node at WICKERSON Studios. We are functioning on some pretty common built-in functions right now, and I will continue with kind of the dealing with points series. Actually, it's more dealing with data. Let's jump in here and build something fairly interesting. Of course, I always forget to delete the one that's up there as an image. Let's just take that to disable. And we'll go on in here. We really don't need anything because we're just producing numbers. So there'll be no, well, we could pull it in the points after and see what we do geometrically with it. So let's slide it back into the shaded. There we go. We'll just start with math. Build yourself your own little node with the Ghpython, which is really what it's all about, just making your own nodes. And this one we're actually going to open up and use nothing because we're not using any built-in functions, the Rhino script syntax. We're just going to use random. And random's an interesting function within Python. And of course, you have to remember to import. You can't just type in random. And we're basically going to produce a series of random numbers. And I'll show you how to do that. One way to do it is use that random modulo of random dot and see what comes up. And one of the choices is random, which is pretty interesting if you think about it. Now, what does that allow for? It allows for basically grabbing a number between 0 and 1 if you leave that blank. And the proof of that is if we ran and random 1 out, you would see that that comes up as rand1, and we have to put that in as our output. It's fairly simple to start. I mean, these really are the basics. Rand1 out, and let's see what pops up on our screen when we hit run. And we, of course, like I said, in good practice, have an out panel for errors and mistakes that will come up in the bottom panel and whatever's coming out of this information. And there it is. And so every time we run this, we're going to get another function. If you look down here in the green panel, test, 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 you're getting those points. Another thing to do is go in, and I'm going to hit copy, go down to the bottom and hit paste, paste, and I'm going to have a random 2. And I'm going to have a random 3. And what I'm going to do is back off on here, back to this section, to the M, and hit dot and see what other choices come up. Well, there's plenty in there, but I'm going to show you a random int. And you can imagine what that kind of does, but it's going to ask for a start and stop. So I'm going to start it at, let's start it at 3 and stop it at 12. And that should be enough. And see if we can get a random integer between there and there by running random int 2, and of course we have to add in a second random 2 output. I have a little girl here singing for you on a Sunday morning. I hope you enjoy it. We will just take a shift over here so we can see by running it what is happening. Random 2, random int out. Of course I didn't type in my output, so it doesn't know what to do. Random 2 out, set to random 2. So you're really just running in your inputs, running in your outputs. Now we can make this much more exciting. I'll show you how exciting it can get. We can go in here and type in type hint integer, because we're doing a random integer, and we can have those slide around between 0 and 100. So let's just pull those into here, X and Y, set the other one higher. And let's change our hard-coded to X and Y within our computational script. So we have our computational script and we have our parametric nodal script. Let's run it again, and now you're able to have some variance on the randoms that are being chosen. And of course, as soon as you slide these sliders anywhere, it's going to change the data. And of course, it resets the top function as well. You can learn how to seed these things later, which I'll All right, so what I did was I went back in and I just played a little bit around here, and I added an integer, s, and I brought in the function random.seed, and then you can seed it with whatever you want. What's nice about that is if you put that in there, you can memorize. So if I seed it 0 and I change these, it'll hold. Pretty interesting, the random at that. The random integer changes as I move that if it's plugging in. But if I wanted to move both values and know what they were at each value, once I've set the domain, or that, let's say, the range of where I wanted things to go from start to stop, say it was 1 to 100, I'd know I could grab each of those values if I recorded this number and knew what I wanted to do. So that's a little added function you can put in there. The last one I wanted to show was random 3. And random 3, you can go in and use a thing called uniform. And uniform is a pretty interesting function if you take a look at it. Help on method uniform in module random. You'll need self A and B, which is basically asking for a start step to the random, which has already been referenced, and get a random number between a range A and B. So I'm going to do that as well, and of course the number coming out of that is going to be a decimal as opposed to a random integer. So I'm just going to do the same with X and Y, and we'll run that as this little shortcut of Control, copy, go into 2, change that to 3, change that to 3, and let's add another output, and we can just go fairly quickly on that. I don't know if this is quicker than typing it. You'll have to decide how fast and dexterous your fingers are. Probably would have been easier to type it. Excuse me. And we'll run that script, and we'll have this output come out, and you'll see that we'll get a random integer between those values. Not integer, random float between those values. And there we go. Pretty accurate, pretty nice. So 3 little functions that are built in without even having to go into Rhino script syntax. The random has a ton of things you can play with. I would suggest going in here when you're done, random, and hitting dot and saying, okay, what is all this wonderful stuff and what does it mean geometrically to what I'm ending up doing? And that's very similar to going into the import math module and finding out everything that can happen within that. And this gets fairly complex pretty quickly, but it is a very interesting thing to play with. That's it. I will zoom back out. Of course, we have nothing to look at, which is kind of boring. Let's grab our random. Let's actually do something with that. Let's go back in and set this up and hit play. Why have I died? Why did my program totally quit on me? Syntax error. Oh, because I was playing in random. It's easy to get ahead of yourself and get a little lost. Let's grab those 3 numbers and do something super exciting, which is not going to be that exciting, but since we have 3 numbers and we have a viewport, and this is about CAD and designing and actually making something in the world, which seems to be something that I do less and less of in my life as I get farther into computational design. We have a point, and there it is, and let's make that little point dance because of our beautiful seed. And with a seed, we could always go in and have fun with our ranges, make our range between 0 and 37, or have as many steps in the range. And there we go, we can make the sucker dance a little better. And because we have how many items coming out? 11 items coming out. Let's grab a little interpolated curve just for visualization purposes. I'm missing the old NURBS curve. I haven't used that in a while. And there it is. And let's throw it into a little pipe just to show us a little action. And for fun, let's even go so far and do what I love to do so often. Variable pipe, reparameterized. Always something nice to throw in at the end. For those that haven't done it yet, it's a great way to grab some geometry. Oh, it's just being a little angry on me. There we go, reparameterized, a little too close to my picture, I guess. And we'll need another range to do this. And because we're dealing with 0 to 1, we can just default at the domain that's going from 0 to 1. We don't have to worry about the steps, but it might be nice to take the curves and know that we have how many points coming out, the range. Let's throw that through a input graph mapper. And into here, take the range into the parameters, graph mapper into the radii, and start playing around with some of these graph types. And once again, when you get too close to that screen, it starts to fudge out on you a little bit. I always love sine, so let's bring up the minimum width and the thick width here. We can make this as thick as we want, and if it's not doing anything geometrically fat enough for us, let's go into a tool that's always produces some very interesting geometry. Let's choose the parabola. Can't go wrong with parabola. And we can jack up the scale and bring this up and start to really fatten that one out. And there we go. It kind of parabolas through itself. And for the caps, we can enumerate through our caps if we want. But I think we'd be best to just throw on a number 2 cap with a quick quote 2 and default to round caps. And there you go. You get something worth baking. You get a dancing little fat juicy worm. I always like to do select all by kind of a frame so it can behave and turn around a little bit. let's throw it through a little bit of the seed and see what we end up generating. All these funky little donkeys and spectacular little forms that could end up being things that you Boolean union and change later. The z-coordinate is coming out as a random 3 integer. I have to think back to my script to what I'm playing off of. From this to this, not really getting the z as to where I'd like it to go. But control your script, know it computationally, know how to play with it geometrically and parametrically, and then know how to go back into Rhino and have some fun with it. But really, put an infinite range of, well, not infinite, 100 little range of what you can do with 11 points. But if you start changing those steps to different numbers, like the amount of steps within this direction, that'll start fudging it and doing some crazy stuff as well. Anyhow, hope you enjoyed it, and we will recenter our page as geometry to the point and beyond. And after this, I think with the random library, we may do some random 2-point grids, which actually we've gotten into a little more. And you can do the random within, if you like, the ranges within the 3-point arrays as well. And we'll end with that before we go into math library. Thanks for watching.